right now, I'm just gonna go over every single piece of logic, what it does, the terminology that I use, terminology that Dreams uses, and just a bunch of boring logic stuff. So, if you don't want to learn any of the basics, this part isn't for you. But, what we're gonna start off with is like terminology. So, terminology. Well, this is sculpt mode. This is a sculpt, but it is also an element. An element in Dreams is basically anything that you make. This is also an element. It's a painting, but it's also an element. This is an element. I can go into this and then get this. This is an element. Everything in Dreams that you can interact with and build upon that isn't logic or gadgets is an element. Of course, then there's scenes and then dreams. And scenes are what I'm building in, and dreams are what you put scenes in to make an actual level. Now, from here, this is our full gadgets menu. We have everything that you'll ever use to make a fully functional game within Dreams, including some sound tools that I'm not very good with. Now, just to start off with, let's get a microchip and place it down. Now, in order to open this, you can hold down L1 and then X. That opens it. And then L1 and square on it will open its properties panel. Properties panel is very important. It shows you anything and everything that that a gadget can do. And you can also, most of the time, tweak it, like the color or the settings of the gadget. Microchips in general are just mainly designed to be containers. So you can just name this to be anything that you want. And you can also put an icon, anything you want, in any color. And you can also dignify, like, what sound channel everything audio-wise on this microchip is going to be. Right? Now, just to go over some inconsistencies that I use, I'm just going to get a value slider. And a value slider is a input, and it is usually set by whoever made the object, but if you share it as remixable, this can be tweaked by anybody else just by opening the microchip that it's in, or if it's in the world like this, they can also tweak it. And tweaking it in this case would be moving the slider with holding down X, or you can open its properties panel and you can move the slider in here. Now, for the value slider, there's the value, minimum, which is how low it can go, and maximum, which is how high it can go. There's also slider visible in scene, so if you just want a floating number, just like 1 or a float, a float is a number with any values, after the first decimal point. So 1, 2, 3 is not a float, but 1.5, 1.6 is a float. And just a number without any decimal points is an integer, and that's what this is technically right now until I do this. So, mainly in my videos and on my streams, I have quite a bit of, like, naming inconsistencies, but just to be simple and to explain what they all are and what they mean, this is a cable or a wire. It's what signifies where a value is going, and a value is what is coming out of the gadget. And you can see these on basically a lot of gadgets. They're on nodes, splitters, and stuff like that. And they come from something called a port. And a port can either be an input or an output. And they are attached to the sides of gadgets, with inputs being on the left, outputs being on the right. And basically they carry the value, and the value in this case is just a direct value from the value slider that you set, over this wire or cable into the input port of this OR gate. So in this case, this OR gate wants 2 inputs, and they're both ports, and both of the values need to be greater than 0 in order for it to output on its result, which is also an output port. And if you open up its properties panel, you can see it can take up to, I believe, 10 inputs, but it needs at least 2 to function. Or actually, it only needs 1 technically. You can have just 1 port and it should work. And it still works, it will still output. So if I get like another OR gate, you can see it still outputs. It's basically saying whatever is coming into here, if it's anything in these inputs are above 0, it'll output 1, which is a Boolean value. And a Boolean value is a true or false value. And it is also equal or equivalent to 0 and 1, and 0 is false and 1 is true. And that outputs into this other OR gate just to show that it is outputting when it is having a value greater than 0. So if we have, for example, at 0.1 and we plug this in, it's going to be partially on because it's not actually it's just basically multiplying by this input. But basically anything greater than 0 usually ends up being true, and if it's not 1, then it's not going to be fully powered. But if it is 1, then it will be fully powered. Now to start off, since I already have like all the terminology down for you guys, let's get started with the gadgets themselves. This is big boy stuff. Not really big boy stuff, it's just standard logic. So the randomizer, this input randomize is basically overriding this. Normally this is just going to be a 1 or a 0 value, but you can change what the value is output with this. Randomize will pick a random port output on of the total number of ports. And so if we test that out here, get like a button and plug it into the randomize. You can see it's going to pick a random one every time. And no repeat means it's not going to pick the same port twice. Shuffle means it picks the port in order in advance and plays this order back each time. So basically, if you have this set up in a game and then you come back, each and every time it's going to be the same. Pure random, complete random, so it can potentially pick the same port multiple times. Not much more to it than that. There's also the active port, so it'll tell you from 0 to 10 which port it is. So 1, 2, 3, 4, 5. So it'll output 5 at this point as a number. Right, and then next is counter. Counters are really easy. It's just basically a integer value that it stores, and it'll tell you it can output if it's full, count progress, which is this number divided by this number, something like so on a 0 to 1, so on a percentage scale, And then increase count makes it go up, decrease count makes it go down, reset makes it resets. And you can also output the current count as well. You can basically input and output almost everything in Dreams. It's pretty cool. Right? And then from here, we have the logic gates. And these are integral to making stuff. You have to understand these in order to understand how the rest of Dream's logic works. You don't have to use these because these are actually implemented in a lot of logic chips already, a lot of gadgets. So basically, this top one right here is an AND gate, which means all of its inputs need to have a value of 1 in order for it to output leave. So if we input this and this, then it outputs. But if this one's turned off, it doesn't. And an OR gate means if any of its inputs are turned on, it'll output. If both of them are off, it's going to be off. But if either are on, it's going to be on. And then the XOR gate is basically only one of the ports can be active. So if I get another one, I get 3. This is easier to show you. So it can be any one of these, and it'll output value of 1. But if it's 2, it's going to stop. If it's all of them, it's not going to output anything. So it can only output one at a time, basically. And then a NOT gate inverts, so it's going to switch a Boolean value of false to true and true to false. So right now it's false, so if I get another NOT gate just to show the output, so you can see it's lit up, so it is a value of 1, press it, and now it's a value of 0. Press it again, it's 1. Pretty simple, there's no other options for it, it's just really simple. Next is a selector. Now, a selector, basically, is a list that you cycle through. So, these on the left here are set. So you can set which output over here is going to be 1. So you can either cycle through them. So I will just plug all of these in this just to show the colors and stuff. You can understand which value is what. So this top one is A, and then it's B, C, D. And you can cycle through it, next, and previous, of course. If I do the previous instead of the next one, I'm gonna go backwards. And you can also do set. So for example, if it's at A and I want it to be C, but I didn't want it to be B at all. I don't want it to make contact with B. I don't want it to cycle through D either. You can plug it into here and then just set it to C directly. Now there's also other settings in here. You can make it a pass-through. So you can actually plug in values to these sides, the A, B, and C, D. So instead of outputting 1 or 0 on here, it'll output 0 if it's not selected. But if it is selected, it'll output the value that's input on the left here. Then one last thing is active port, and you can actually set this. So if you have it as a pass-through and you want it to set to B, you can actually input that the number 2, and it should set it to B. And next we have an exclusive gate. And exclusive gates basically are a very special logic bit, and you need more than one of them in order for it to fully work. And you actually need to name them in order for it to fully work. So we're going to have this as T for test. And we're going to name the other one as T for test as well in the properties panel. And basically what these do is allow only one input to be active at a time. So if you have, for example, a dialogue system set up, but you only want them to say one thing at a time, you can use this to have it so if the player is attempting to have them say two things at the same time, only one of these will trigger. So we will put down, we'll take our switch up here actually, and I'm going to get another one and another one. I'm going to plug this into the gate input, and this is going to be setting it. So we're going to want to do this. This is going to turn it on. And we'll put a splitter back here. A couple of them just to get the output here. And active means that this gate is turned on and it is allowing the signal to pass through. So now if we press this button, this gate is open, meaning that this gate can't. So if we turn this on, the value isn't going to go through no matter what we do. If we turn it off, then the gate is going to open. There are other settings for this. For example, manual. Manual means that you have to reset the gate before it opens up, before it closes and allows other ones to open. So if I set both of these to manual here, it's going to open up this one. And now if I stop it, it's going to stay open, but it's not going to pass through the signal. However, if I try to open this one and send the signal, it's not going to work, because this one is currently open and you can only have one gate open at a time. And you can close the gate and then send the signal for the second one, and the first one isn't going to be able to send it until you reset it. And then Q, it's kind of confusing, but it allows for it to like be going through a list, kind of. So if I do Q, I want to get another one, and I'm going to send this here, and I'm going to copy this switch, plug in the output to the gate input, another splitter to show off the output. So if I just turn this one on, and then this one, and then this one, what it's gonna do is if I turn this one off, it should, I think it's, yeah, okay, no. So if I have it reset and close everything, since this one turned off and this one came on second, this one's gonna open. Then I can close this one and then reset it again, and then this one will finally open. And that's how the queue works. Normally it would do priority, but if you do queue, it's gonna go through whatever was open first. And priority means if you have it set to automatic, it's gonna try to go for the one with the lowest, I think. No, probably the highest priority, yeah. Whatever one has the highest priority. So if, for example, you open a gate and then open two other gates at the same time afterwards, whatever one has the highest priority is going to pick that one first. Interrupt means if this one is set to interrupt, and I'm going to set these all to automatic. If I turn this one on and then turn this one on, it's going to turn off this input and then go to here, because this one has ultra priority, which is interrupt. And then it can switch back. And that's basically gates. there's not much else you can do with these. I'm not entirely sure how to do gate sync, but they're pretty complicated. Right, next is the signal manipulator, and the signal manipulator can be used to do a lot of things. Really complicated. Its sister gadget is the signal generator. This is basically kind of doing the same thing, but instead of like generating a signal, it is manipulating one. So for example, you can set an input to smoothly go up and to smoothly go down. So if you input 1 here, for example, it's going to make a little graphic here. So we're going to have 1, and the input on the left is going to be 1, but this one goes up over time till you reach 1. And when you turn it off, it's going to do the same thing to go to 0. It's going to slowly fall to 0. So that's smooth rise and smooth fall. Freeze output basically means to freeze it. So if I set this to higher time, like 4.2, and then I freeze it, it's going to stay at that value. So you can use that to pause. Right? And then pulse on input on means instead of being a constant signal, it's going to pulse. You can also do the smooth rise and the smooth fall. So it's going to go up and then down very quickly instead of being a constant on value. Invert output is not very intuitive. Basically, it's kind of like a NOT gate, but not really. So turning it on is going to have it turned off, and then turning it off is going to have it be turned on. I think that's like just 0 to 1 and stuff like that. Of course, there's still the smoothing, and then over here is the custom remapper, and this is where it gets really complicated. It's not very intuitive, but you would probably be able to figure this out by reading the descriptions of everything. Edge mode is basically a more complicated thing of pulse on input on, because you can pulse it on, pulse it off, pulse at on or off, toggle, so it can be like a button, at on, toggle output at off, and toggle output at on or off. And from here, up here you can change the input to be like 0 to 1, and you can make it from 0 to 100, or from 1 to 0. You can flip the values as well. And of course you can shape things, and it's all very, very complicated in here. It needs its own like explanation basically. I think I actually have a video about it. I'm not entirely sure. And then from that, we have a timer. Very simple. If nothing is plugged into the start timer, it's going to start automatically. I think. Yeah. And there's different timer types. So there's count up. So it's going to go from 0 to the target time. Or there is speed. And basically this changes with whatever this is. So if this is negative, make this a, and it can go backward. So that, and then of course negative, and it's go backward. That's what speed is. And positional is kind of like not very intuitive, but basically if you turn it on, it'll go forward. If you turn it off, it'll go back. Pretty good. But then there's also countdown, kind of weird because you need to force the current time to be reversed, and then you press it. There's not really a good way from what I can tell that it. So if we go into this and then reset it, you can see it doesn't go, even though it's set to count down. There's a start timer, timer finish, so when it gets to the end, is this, it'll output, so I don't know if it'll go, if it'll pulse when it's done counting down. It will. Okay. Reset timer resets it to 0. Timer output is 0 to 1 scale on how finished it is. Timer finished is a 0 to 1, just absolute. 0 is it's anywhere between counting and not doing anything, and then 1 means it's completely full, done counting. Right, and then the calculator. Have a lot of different math stuffs. Basically, this is the left side, operand 1, and this is the right side, operand 2. There's add, subtract, multiply, divide, greater than, equals, less than, remainder after division. So this would be A divided by B, and then there's minimum. Some of these only have one value, so I think minimum, not entirely. Return whichever is smaller of operand 1 and operand. If A is smaller, it'll output A. If B is smaller, it'll output B. And then there's maximum, of course, power of, round down, round up, absolute value. These bottom 4 only take one value, A, of A and B. Alright, and then we have microchip. That's what this is. Been using microchip full time. And then we have a node. A node is basically a gadget that has an input and output, and it just basically allows input to travel to the output. And this is helpful because you can use nodes to make outputs on microchips. So that node that we had is now a port on this microchip, which is really useful if you want to publish microchips to the universe and let other people use it. So you can have input ports, output ports, which basically is the node on the left side will be a input port, and it will allow you to get things from outside of the microchip as if it was a port. And then you have the output, which is outputting value that you decide. And no port is just a pass-through, basically, which shows first saying. And from here, it's just basically just outputting the value from one side to the other. And you can also turn these off, so you can use these to make like better AND gates, kind of. Like you can use this as a pass-through AND gate, so instead of like being a value of 0 to 1 with an AND gate, you can output the actual value that you want instead of just 1. And that's basically nodes. And I think I've already gone over splitters and tuners, but splitters take a fat wire and it will output it to multiple thin wires, and a combiner will take multiple thin wires and turn it into a fat wire. And then variables. Variables are very important if you want to make something like an RPG, because you can use variables to make like an inventory or stuff like the status of a quest and complex stuff like that. So by default, their initial value is 0. The minimum value that they can have is negative 1,000, and the maximum value is 1,000. And a variable can persist in a dream, meaning that it can exist even after you close the dream. So if you quit the dream, the data that is stored in this variable is going to stay the same when you come back. So you can use this as a persistent inventory or any manner of things that you want to save in a dream. So you can make anything these basically for a save system. And multiplayer means that it'll be a different variable for each player in the scene. And this is another like special named thing, so you have to name variables. And that's how you are able to actually store the data. You can't just have a variable that's not named, or else that won't work. There's also current value is the current value, and then increased means that somewhere in the scene a variable modifier caused this to go up. Decreased is the same thing, but it caused it to go down. And variable modifiers take a name of a variable, and you're able to either set the variable, get the variable, add to the variable, and it's also subtract from it as well, or you can reset the variable. And there is one powered on, which is basically once when this is turned on, or continuously while powered means it will constantly do the operation that you set. And if you do set, you can set a value here, and if you do add, you can also set a value here. Get and reset, however, do not have an operation value. And they are very complex, so you can use them for many things, and they're very important. And I think I talk about them more in the RPG series if you're interested in that.